Hi everyone, welcome back to my channel. Today we are going to discuss some important formulas of determinants which are useful for EAPCET exam. Okay, so first of all I'm taking one 2 by 2 matrix, that is ABCD. So determinant of this matrix is nothing but AD minus BC. We all know about this, right? Next, I'm taking one 3 by 3 matrix here. A, B, C, D, E, F and G, H, I are the elements of the 3 by 3 matrix. And here if I take a element A and deleting the corresponding rows and corresponding columns of A, here we are left with the submatrix, that is EFHI. If we take the determinant of EFHI is EI minus FH. So A into EI minus FH. In the same way, if I take B element, I am subtracting the corresponding rows and columns of B, and we are left with DF, GI are the elements. If I take the determinant of DF, GI, DI minus FG is the determinant. Next, if I take C here, and here if I deleting rows and columns of corresponding rows and columns of C, we left with D, E, G, H are the elements, and the determinant of D, E, G, H is nothing but DH minus EG. So if I am writing here the determinant, A into EI minus FH minus B into DI minus GF plus C into DH minus EG is the determinant of 3 by 3 matrix. Now let's discuss about minor of an element. Here in the minor of an element, we are deleting corresponding rows and columns of the element. If we take any element and if we delete the corresponding rows and column, and finding out the determinant of the remaining elements is nothing but minor of that element, and we denote with MIJ. Okay, next, cofactor of an element. Cofactor of an element is nothing but -1 whole to the power of I plus j into minor of an element. I and j are the rows and columns. Okay, -1 and -1 whole to the power of I plus j into Mij. Here if you observe here, I am taking the signs. For 3 by 3 matrix, if you find out the cofactor of an element, here the signs will be like this: plus, minus, plus, minus, plus, minus, plus, minus, plus. Whenever you find out the cofactors, and if you write the matrix here, cofactor matrix, the signs will be plus, minus, plus, minus, plus, minus, and plus, minus, plus. Okay, next, to find out the determinant of 3 by 3 matrix, there is a shortcut here. First of all, I am taking all the elements of 3 by 3 matrix. Then after, I am taking the first two columns of the 3 by 3 matrix. I am writing again here after the third column. Okay, I am taking again here. Then after, what I am doing here is I am taking the diagonal elements. First element to diagonal elements are A, E, I. Product of A into E into I plus next taking B into F into G, diagonal elements I am taking downward, plus C into D into H. So AEI plus BFG plus CDH are the downward diagonal elements. Next, if I take G element, GEC are the upward diagonal elements, and HFA are the upward diagonal elements, and BDI are the upward diagonal elements. I am multiplying G into E into C plus H into F into A plus I into D into B. So I am adding all these upward diagonal elements. If I subtract downward diagonal from downward diagonal elements, I am subtracting the upward diagonal elements, so that we will get determinant of the given matrix. Okay, and here some key identities we'll discuss here. A into adjoint of A equals to adjoint of A into A, and this both equals to identity matrix I. So next, modulus of adjoint of A, that is nothing but determinant of adjoint of A is equals to determinant of A whole to the power of n minus 1. Okay, next, adjoint of A equals to determinant of A whole to the power of n minus 2 into A, where n here is order of matrix. Okay, if it is 2 by 2 matrix, n equals to 2. If it is 3 by 3 matrix, n equals to 3. Like that we will take. Next, determinant of adjoint of A equals to determinant of A whole to the power of n minus 1 whole square. Okay, next adjoint of A into B equals to adjoint of B into adjoint of A. Next, orthogonal A into A transpose equals to I. And what is the determinant of this orthogonal matrix? Is determinant of A equals to plus or minus 1. And next, idempotent matrix A square equals to A. Involutionary matrix A square equals to I. Nilpotent matrix A power m equals to 0. Here m is the index. And if the determinant of A is equals to 0, we call that matrix as singular matrix. Here there is no inverse. And if determinant of A is not equals to 0, this we call as non-singular matrix and inverse will exist. Next, here determinant of A equals to determinant of A transpose. Both are equal. Determinant of A into B equals to determinant of A into determinant of B. Determinant of K into A equals to K power n into determinant of A. Here n is nothing but order of matrix. If the rows or columns are interchanged, then sign of the determinant changes. If rows or columns are identical or proportional, same rows or same columns, or both rows are proportional, then the determinant is 0. And here determinant of A power n equals to determinant of A whole to the power of n. If above or below leading diagonal elements are 0, then the value of determinant is equal to product of leading diagonal elements. Okay, if above or below above and below leading diagonal elements are 0, then the value of the determinant is equals to the product of the leading diagonal elements. Next, if a determinant of nth order, number of elements in determinant, how can we find out the number of elements in 3 by 3 matrix is nothing but 3 square. 3 square it means 9 elements will be there. Like that, for nth order, the number of elements in the determinant equals to n square. Next, the maximum number of operations can be done at a time equals to order of determinant minus 1. Order of determinant minus 1, that means we can add the rows or subtract the rows, columns, like that. No, the maximum number of operations we can done at a time equals to order of determinant minus 1. Next, if we take system of linear equations here, like a1x plus b1y plus c1z equals to d1, and a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3, then here delta is the main determinant. Determinant will denote by delta. Delta equals to here a1, a2, a3, b1, b2, b3 and c1, c2, c3. That is nothing but we are taking the coefficients of the variables and finding the determinant here. Then after determinant 1, delta 1 equals to, we are replacing x coefficients of x with constants d1, d2, d3. Okay, here column, here first column are nothing but coefficients of x. These coefficients of x are replacing with constants d1, d2, d3. Next b1, b2, b3, c1, c2, c3 are as it is. So to find out the determinant delta 1 equals to, we are going to take this determinant. Okay, and to find out the x value here, x equals to delta 1 by delta. Next, if we need to get delta 2 equals to, we are replacing the coefficients of y with the constants here. Okay, a1, a2, a3 as it is I am taking, and here d1, d2, d3 are the constants. Next c1, c2, c3 are the coefficients of z. Okay, next y equals to find out the y, delta 2 by delta is the formula. Next, to find out the delta 3, that is nothing but determinant 3 equals to a1, a2, a3, b1, b2, b3. Next, z quotient of z elements are replacing with here constants. Okay, so here a1, a2, a3, b1, b2, b3, d1, d2, d3 we are considering. To find out the z here, I am taking z equals to delta 3 by delta. If delta equals to 0, that is determinant equals to 0, we call the system of linear equations have unique solutions. If determinant equals 0 and also delta 1, delta 2, delta 3 equals to 0, we can tell that infinite solutions are there. If delta equals 0 but any of the determinant delta 1, delta 2, delta 3 are not equals to 0, we call that as no solution. Now if we have x1 comma y1 x2 y2 x3 y3 are the vertices, then how can you find out the area of a triangle? There is a formula to find out the area of a triangle here. Delta equals to 1 by 2 determinant of x1 y1 1 x2 y2 1 x3 y3 1. First column all x vertices, second column all y vertices, third column all ones we are taking. Okay, next, if the equation of a straight line passing through the points x1 comma y1 and x2 comma y2, then the determinant, how can you find out the determinant? Here is I am taking all x are on first column and here y vertices are on the second column and 1 is in the third column. Okay, x y1 x1 y1 1 x2 y2 1 we will take here. Determinant of x y1 x1 y1 1 x2 y2 1, that should be equals to 0. If the three lines, those are a1 x plus b1 y plus c1 equals to 0 and a2 x plus b2 y plus c2 equals to 0 and a3 x plus b3 y plus c3 equals to 0 are concurrent, then determinant of a1 a2 a3 b1 b2 b3 c1 c2 c3 equals to 0. Next, rank of a matrix. Generally we can say rank of a matrix is nothing but number of non-zero rows. Number of non-zero rows. If the determinant is not equals to 0, rank of A is nothing but order of matrix. If the determinant is equal to 0, we will check the submatrices. We will check if any rows having non-zero elements or not. Okay, and here see, if we have 0 matrix, then the rank is 0. If any row or column is a multiple of another, then we can say they are dependent and we can reduce the rank immediately. Okay, by deleting the rows or by deleting the rows, we can make the rows equals to 0 to find out the rank here. Okay, I hope this video is helpful for you. If you like this video, please share this video to your friends, those who are preparing for EAPCET exam, and also please like and subscribe to my channel. Thank you. Bye bye.